All right, let's dive right in. So today we're talking about how you should forget platform engineering and rather think about developer productivity. And what we really mean by that is when you're building platforms for developers, a lot of customers are looking for a more customer-centric approach to building them. And the customer in that case is, of course, the developer. So what's the gist of the talk you're seeing today? Well, we are asking you to not lose yourself in the traditional way of building platforms, which often means running a lot of systems on your own, running a lot of infrastructure, keeping this up day and night, and really losing a little bit of sight of what's really important, and that's developer productivity. Instead, we want you to really compose and integrate ready-made services so that you keep your head clear for really thinking about your developers. And in the second part of my talk today, we're talking about how you can actually do that. So we will give you some frameworks, some thoughts about how you can think about developer productivity, and then work backwards, as we like to call it at Amazon, from your customers, the developers, to create the right developer platform just for them. But before we really dive into it, let me give you some context. Let me go back in time so we can think about where it all started. In 2006, Werner Vogels, the CTO of Amazon, he had this catchphrase, and he said that when he was talking about what's a good way for product teams to build digital products, and what's a good way for those teams to work and operate. And he said, well, a good way to do it is you build it, you run it. So the idea is that developers really should be in contact with the day-to-day operations of their software. And he really sees this as a critical feedback loop for improving the quality of a service. And also around that time, maybe a few years later, this whole idea of DevOps started to emerge, right? So we were thinking about how can we move operations and development closer together. So all in all, great ideas. But fast forward to today, there's a little issue here, and you can see it here. It's actually quite a big issue if you open the page. So I don't want to throw the CNCF landscape under the bus here, but the idea is basically there's a lot of cognitive load that a developer has to deal with today, right? There's lots of services, and you do not even just have to think about how to code your service, build your service. You also have to think about delivering it to production, adding observability, dealing with containers, and all these kinds of things. So that's actually where platform engineering tries to come in and tries to reduce that cognitive load for the developer and make them more self-sufficient, make them more autonomous. And another way to say that, and I like this quote a lot from ThoughtWorks, is that platforms, for example, developer platforms, are a means of centralizing expertise while decentralizing innovation to the customer or user. So that's great, right? We can build a platform that helps developers make their lives easier and get their code on the infrastructure and so on. And if you want to think about how this could actually look like, again, I'm pulling from the CNCF here. This is like a very high level overview of how such a developer platform could look like. And you might have seen this picture or other pictures. There's lots of pictures that are almost all the same. And you can see essentially that in the middle, there's a bunch of platform capabilities that you want to offer to your developers. So of course, you need compute, networking, a database, messaging queues, identity management, these kinds of things. And then on top of that, you want to provide some interfaces. So ways to make the platform more accessible to users, like documentation, templates, maybe a CLI to put those services together. So again, great idea, great concept, makes a lot of sense. There's still a challenge here, and that's you can actually spend a lot of time building this out, right? There's lots of boxes essentially for you to check. I need all those services, and in some sense, you can lose yourself in building the perfect platform. And this is something that we sometimes see with customers and their platform teams, is that they have a very technical view. They are really great at building those things, but there's a slight risk of over-indexing on building this textbook platform instead of focusing on what your developers really need. And sometimes you spot those signs that maybe the platform team could kind of course correct a little bit. So what are these kinds of signs that we might see? That's what I like to call the downward spiral of platform engineering. And the essence of it is running too much and the wrong things that actually developers do not really like or do not really use. To go a little bit into the details here, it all starts with step one, which is prioritizing the wrong work streams and features. And then it's often followed up by reinventing the wheel and building undifferentiated services. And these two things often happen because you're not close enough to your user, to your customer, which is the developer. So you're not gathering enough signals, enough data about, okay, what's actually the biggest friction point for my developers? What's actually their problem? What is holding them up during the day? And instead, you're really focusing on these building out these really big enabling services that might not necessarily be what the developer needs right now. So if you're down that path, often there's another problem that arises. And that's, now you have built all these services, these platform services, maybe even on top of cloud. And now you're spending most of your resources, most of your capacity, most of your team time on operating those services. And that can be very frustrating for platform teams because they feel like developers are asking them for things all the time. Hey, can you add this? Can you do that? But they feel already super busy with just keeping the services running that they already have. So they are kind of have tied up all their capacity in just keeping the lights on, essentially. So typically, you can find that if you're doing things like running Kubernetes clusters or running Kafka clusters on your own, there might be reasons why you want to do this. If you do something very specific, if it's like a differentiating service for you for whatever reason, or if you're doing something that's very industry specific. But for a lot of customers, it's really a commodity service, and there's not too much value in running these services. Moving further down the spiral from there, now you have all those services, and there's another problem coming up, which is the developers, the platform teams, they really feel now that their identity is tied to the services, right? It's the Kubernetes team, it's the Kafka team. So for those teams, this is their reason of being. And that can make it really hard to change these services, maybe deprecate them, switch them out against another service, because the team thinks like, hey, this is my foundation. That's why I'm here, basically. So we have like interesting discussions where, engineering leaders of customers are even like, maybe I should call my Kubernetes team actually compute team. That would make, their job description a little bit broader. And they would feel like there's more to do than just running Kubernetes. So again, this can actually make it hard to, be a nimble platform engineering team and really also improve things when you want to switch out a service. There's another fallacy that comes up sometimes, and that's actually you are believing you're good at building abstractions. So, essentially, if you think about programming, we have abstractions like classes that try to abstract away certain details of the implementation. But when it all fails, you still get the full stack trace, right? And you can see down the guts of the program. And you're like, oh, that's what's actually going on under the hood. And platform engineering is similar in some of those aspects, right? There's a lot of talks about, hey, we're doing platform engineering to reduce cognitive load, to abstract infrastructure and whatnot. But building good abstractions is actually really, really hard. And one reason why it's really hard is that oftentimes when people think about abstractions, they're thinking about just the template, just the configuration time abstraction. Oh, I just put together a template, it does these things, it adds these services, and then it's done. But the problem can often start when actually this stuff is running in production and something breaks, and then the developer opens up the Kubernetes UI, the console, the CLI, and they see all those guts that they have never seen before, and now they feel like, oh, I actually don't know how this works. So this is why looking at cloud services that try to abstract things away at configuration time and runtime, for example, things like serverless, can really be a big bonus here. And it's sometimes it's actually overlooked that runtime abstraction is super important to be productive as a developer. Now, up to this point, in our fictional misery story, we made a lot of mistakes. And to basically lock us in our mistakes, one thing that can happen is that you kind of create your own echo chamber as a platform engineering team, which means you are measuring things, you're asking people for feedback, but you do not do it in a very broad way. Instead, you're really asking about, hey, I got this service, I got Kubernetes, I got Kafka. Do you like these services? Yeah, great. Okay, then I move on. And you're not really leaving room to ask, hey, let's leave aside the services we have today. Just tell me about your workday. What's really nagging you? What feels like it takes a lot of time? What feels like very hard to do? And it's really important to get this feedback as well, to work backwards from your customer, as we say. Now, summing up all these problems, all of this downward spiral, Charity Mayers, who's the CTO at Honeycomb, I think she framed it really nice in one of her recent talks, which you see on the bottom right: perils, pitfalls, and pratfalls of platform engineering. Can definitely recommend checking out that talk as well. And she said it very nicely. She said, well, you have a platform engineering org which wraps and packages your infrastructure needs by running as little infra as possible, right? And that was exactly the problem we saw in the downward spiral. A lot of stuff happened because we were over-indexing on running infrastructure on our own and not leaving enough space to actually go to our developers, ask them what their problems are, and basically replacing platform engineering with the idea of, hey, in the end, we just want to improve developer productivity. And that brings us to the beginning of the talk, brings us back there. So we said, hey, we want to spend the resources on the right things, and we want to think about developer productivity first and work backwards from our developers who want to be more productive. And now I'm saying, well, it's super nice buzzword, right? Developer productivity. But how can I actually do that? I have no clue. And I didn't have a clue either. But a lot of other smart people had a clue and they wrote a paper about it. And their answer is the DevX framework. So, what is the DevX framework? It's a framework for a more customer-centric approach to improving developer productivity. And it's actually brought to you by the team that invented also the other very well-known frameworks in that area. So you probably know Dora, you might know space. These are the same people, and this is basically the next chapter of their research and thinking about how you can make developers more productive, how you can measure it, and how you can get good feedback. And essentially, they're saying developer productivity is very much expressed through developer experience. And we are modeling developer experience in 3 core dimensions that you see here on the right side, which are feedback loops, cognitive load, and flow state. And these things really help you to now model the developer, let's say, as a more complex being that really has those needs to be productive. And if we go through the separate points here, essentially you have the feedback loops, and you can probably guess what that's about. So when a developer makes a change, is the feedback fast? Do they have the right tools, the right observability to get feedback very fast in their CI/CD pipelines? And then you have the cognitive load. So that's what we already talked about a little bit. And it's typically where, platform engineering tries to break in. So how much stuff do developers need to keep track of in order to complete a task, to build a service, to deliver it, to run it in production? And finally, the third one is flow state. And that's really about how easily and how often are you able to get into that zone where you are super productive, laser focused on writing your service and bringing new features to your end customers. What I really like about this framework is that, again, it's very user centric, right? We're trying to get a deeper understanding of our customer, which for the platform engineering team is the developer. And it's putting the developer really at the center here with a more comprehensive, more holistic description of how a developer works, right? How they function, what is important to them. And speaking about working backwards from customers, that's really something we love to do at Amazon. Jeff Bezos, our founder, famously said that being customer centric is a great approach, because one of the biggest benefits is that customers are always dissatisfied, even if they are reporting that they're happy. And so there, the DevX framework really hits home for me, because it gives us tools to zoom in on a very specific customer, the developer. And it helps us to understand more this specific customer type. And it helps us to ask the right question. Talking a little bit more about working backwards, this is like a general process we have at Amazon that you can use for almost anything to build a product that delights customers. And it typically starts with asking 5 customer questions that you see here on the left. So who's the customer? What's their main problem? What is the solution and the most important benefit? How can we describe it to the customer? And how we can test it and measure success. And for all those questions, right, the DevX framework can really help us to ask the right questions, and how that looks like we will see just on the next slide. And then if we go further in the working backwards process, what we typically do is we write a press release. So it's like a fictional release of the service, where you write down, how your developers are delighted with X feature or way to build services, to release services. And also we typically attach like super scrappy visuals, so you can, scribble down something, how it looks for developers. Maybe there's a portal, maybe there's a CLI, maybe not. And we also write an FAQ to add even more details, typically hard questions like, okay, what is it really about? Cut the marketing talk. What is it really? What is it not? What is missing? And so on. And then with this fictional product announcement, we put ourselves in the shoes of the customer, or the developer in that case. And from there, we can go on and actually build out a prototype and then scale that. Now, we said that this working backwards process can be applied to anything. So it's like very generic. And now we want to do this specifically for platform engineering for our developers. So how can we do it? Well, we take the DevX framework and we use that to refine how we approach the working backwards. So in the DevX framework, and again, that's from the paper, there's multiple layers in which you basically find out how your developers are feeling right now and what could be improved. In general, there's one dimension, which are the three things we talked about before. So the feedback loops, the cognitive load, and the flow state. And then it goes into multiple layers to dive deeper. So the first layer is really getting the perceptions of your developers. There you ask things like, for example, for feedback loops, hey, how satisfied are you with checking out code, making a change, running the tests, and so on. For cognitive load, you might ask, hey, how easy is it for you to debug a production system? And then if you go to flow state, you might ask, hey, do you feel like you can regularly go into flow state? How long can you go into flow state, and so on? And this is really how you kick off this working backwards process, because you can do this as a survey, maybe company-wide, maybe per team, but you can also use this as a blueprint for an interview. So you might, so we're at Amazon, we're really fond of just talking to customers. And we've seen that, even talking to a few developers, some selected developers in your company can already yield great results in getting an idea of, what are the common problems? Where do they need help? What do they want to rant about? Essentially, that's what you want to know. So you can either do this as a survey and or as an interview. And this is how it all starts. But from there are like even two more layers. So one is the workflow layer. And there, again, in the three dimensions, we're trying to get more objective metrics on the whole thing. So you see some examples here, like, for example, for feedback loops, you want to see like how much time does it take to run the CI pipeline, or what's the code review turnaround time. So these are more hard metrics. You can ask them from developers and basically ask for an estimation, but you can also collect those metrics really from your system by instrumenting it, by creating a report. And the way to use that workflow section here is really to base the input you got in the perception row. So the idea is here, maybe developers are telling you, well, in perceptions, developers are telling you, yeah, everything's great. But if you look at the actual metrics of the workflows, you're seeing that, oh, actually, at least from the outside, it looks like this could be much faster. We could deliver software much quicker. So at least it gives me a pointer to say, hey, maybe I want to dig a little bit more into that with the developer next time and figure out, hey, how do they feel about this taking X amount of hours? Do they think this could be faster? And this is a trend or a theme with all of those layers, is that you do not just do one of them. You need to do all of them together. Otherwise, it's not working. Because you need a lot of context to actually understand things, right? If you just would do the workflow part, where also in the workflow part you could imagine to put your DORA metrics there, it's great as a high-level metric, but without the perception part, you're still not sure if you have the context, right? So if a DORA metric is telling you, oh, this is very slow to release, maybe there's a reason for that. And that reason you only get to know if you also do the perception part of the framework and actually ask developers, hey, why is that slow? Or do you actually feel that is slow? That is holding you back, or is it just fine? And finally, to top it all off, there's this KPI dimension. And the idea of the KPI dimension is just that you want to have a metric for the overall perceived ease of delivering software. So you want to have some metric that shows you that with all the changes you are making based on the data you collected in the other areas, overall, you're actually moving in the right direction, that things improve. So you can ask things about employee engagement and satisfaction, or their perceived productivity. And in general, you want to see that this metric at least not going down, but ideally it should be going up. It's not a hard target, like you're not saying, oh, I want this KPI to be X, but it's more about, a general guideline for you to see, oh, yeah, things are actually improving. I did something here and there, and I added this service, and in general, people still feel like it's improving. If it's going down, you need to wonder, like, okay, maybe I made things worse for some reason, and I need to dig deeper into that. So summing this all up, how could this working backwards process from your developers look like? So in the general process for working backwards, we have these multiple phases, like listen, define, invent, refine, test, and iterate. And coming back to the DevX framework, in the very beginning, right, you together with like a core group of people at your company, you really study a little bit more about developer productivity and experience. So for example, you take a deep look at the paper I just mentioned, and you basically line that, hey, actually our core mission is to improve developer experience. That's the main thing. It's not implementing Kubernetes, it's improving developer experience, because that will lead to better developer productivity. And from there, you go into the listen phase. So you're asking, okay, who are actually my developers? What are they doing all day? And developers is a very high level term. It's like can be very different depending on your industry, depending on the use case. And what insights do we have about them? And this is really where you can already start applying the DevX framework with the questions we just saw. And it's not just about the questions we saw on the last slide. These are just examples, but you can also come up with your own ones. The rule is just that you need to cover all the three dimensions we talked about. So feedback loops, cognitive load, and flow state. So you would ask about that. And from there, you would figure out like, okay, what are the trends? What do I see from surveys or from the interviews I'm doing? What is like the prevailing developer productivity impediment that I want to attack, basically? And what could be a good solution? And what's the biggest benefit of that solution? And when you refine it, you can go back to your developers. So that's really important. Say, hey, you told us this stuff. We have an idea how we want to solve it, what we want to give to you to make it easier. What do you think about that? And if at this point your customer is still saying, yes, that sounds great, that's exactly what we want, you can start in testing and iterating on that to see like, okay, is it actually working? Let's build a prototype. Let's have a hands-on session together with the developers. They try it out. They tell us if they like the template, if they like the feature, the service, the UI. And from there, you can, further go on and take that minimal lovable product you just prototyped and really scale it out as a platform for your whole company. So to sum it up, we want you to spend resources on the right things. We want platform engineering teams to spend resources on the right things. The community sees that thinking about developer productivity first and foremost is a really great way to do that. You can combine that with a working backwards approach I just showed you. So really putting the developer as the customer in the center and asking about their problems and friction points. And the DevX framework is one good way to actually frame what a developer is, how they work, and finding those productivity gaps. And this can lead to a number of improvements. So for once, platform teams might actually figure out that, hey, improving developer experience, that's actually my core identity. My core identity is not X service or Y service. It's actually improving developer experience. And that helps me to, broaden my viewpoint, consider new solutions, consider more scrappy solutions, not going overboard with like cool tech that maybe developers do not necessarily need. And when opening up those different solutions, you can actually find that some of them might be like super simple. So it could be just a wiki page because you figure out, hey, developers really just need a few bullet points on how to get started. They just need a bunch of infrastructure as code templates because actually from cloud, we get a lot of services already. So they just need some good templates that we build from them. Maybe we want to collaborate on these templates. And maybe also, and that's the greatest point here, by running less services, your platform engineering teams get more headspace to actually think about all the new ways on how to improve developer productivity. And one of them is, of course, Gen AI companions, which is like a whole new category of things you can do to help developers. And to make that point very clear that, getting more headspace for new solutions like Gen AI is important, I will now hand over to Christian, and he will give you a glimpse into the future of those Gen AI companions. And we will show like why platform teams and developers should really take a close look at them. So handing over to Christian, please take it away.
Thank you very much. Yes, this part of the talk will concentrate on how to unlock the next productivity frontier with generative AI. This is quite a bold statement, so let's look at some data points first. That's a McKinsey study, and McKinsey tried to estimate the global annual Gen AI impact here. And what you can see is that 75% of the estimated global annual Gen AI impact actually stems from just 4 functions, and they are marketing and sales, product and R&D, customer operations, and software engineering. And software engineering really sticks out to me. If you add those 2 data points up, you will end up at roughly 900 billion global annual Gen AI impact. That's quite a lot, and this is majorly driven by productivity. So, but before we go there, how to actually measure productivity? Robert already discussed it very briefly. I will go a little bit deeper. So the most popular metric is, or framework actually, is DORA. And this focuses on change lead time, change failure rate, time to recover a service, and deployment frequency. A more recent one is SPACE. And SPACE is recognizing that development actually is a very socio-technological process. And they added metrics, especially in the area of satisfaction and well-being, communication and collaboration, and efficiency and flow. The most recent one, the most recent framework, is developer experience, which Robert also mentioned. And the dimensions they are closely looking at is feedback loops. They want to shorten feedback loops. They want to reduce the cognitive load, and they want to increase the flow state. So Gen AI will change a lot of what and especially how we measure productivity. Thinking about activity and output-based metrics, they will get even less useful in the future. But the mental model, especially behind SPACE and DevX, this will hold true also in the future. If you increase the flow time, if you reduce the cognitive load, and if you shorten feedback loops, you will eventually increase developer experience and productivity. So to sum it up, basically, there is no single dimension to capture productivity. You will need to look at multiple dimensions. And it's also not enough to just look at quantitative data from your telemetry. You also have to interact with your user base, your developers, maybe with surveys. So always combine quantitative and qualitative data. And a recent research paper around developer experience actually found that developer experience might actually be the best proxy metric when you want to measure developer productivity. So, but how do we increase developer experience, right? How do we do that? And there is a study from Harvard Business Review, which basically says employees, and this is not only developers, this is all employees, are much more engaged and much more likely to stay beyond 3 years if they have the right technology supporting their work. So the right technology can mean a lot, right? This can be tools, this can be platform, and can be GenAI. And another McKinsey study showed that GenAI can really improve developer experience. This study basically shows developers are significantly more happy, they are more focusing on meaningful and satisfying work, and they are more often and longer in the flow state. And thinking again about developer experience, this is exactly what you want, right? But enough of all those studies. Let's check a use case now. And the use case, I guess everybody knows, is coding companions. They transform natural language to multiple code suggestions, right? For function blocks, they do match your developer style. They hopefully know your internal code base, so your internal methods, libraries, to be actually able to be very useful, also based on your internal code bases and knowledge. They do security scanning and open source reference tracking. So that's great. My observation, however, is that the adoption rate, especially in enterprises, large enterprises, is very low. I couldn't find any data points, any study for that. But if you would ask me to guesstimate, I would say it's less than 20%. And this is actually something I would like to ask you. Like, if you're working in a large enterprise, is your company really adopting coding companions at a large scale already? So I would really be interested in that. Maybe let's cover that in the Q&A. The good thing is, if the adoption rate is low, then there's a lot of potential to actually improve developer experience. And how can you do that? Like, by using a coding companion, and just a few weeks will not help. You need time to get used to a tool. But eventually, you will end up being more likely to complete a task successfully, and you will do so on an average more than 50% faster. Thinking about space and DevX again, there must be more to it. And yes, there is. Developers do feel more productive. They spend less time searching, they're longer in the flow, and this overall leads to a higher job satisfaction. So that was coding companions, and that's great. But developers are on average just coding 4 hours and 21 minutes. And that's per week, that's not per day. That's actually just 52 minutes per day. I was diving a little bit deeper in that study from software.com, and it basically shows that 90% of all developers are coding less than 2 hours and 10 minutes per day. Well, first, this sounds somewhat odd. It does make sense, right? Development is much more than coding. And now, and I promise, this is the last study I'm going to show, a Gartner study that shows 73% of all time, developers are actually running and maintaining applications and not focusing on innovation and transformation. Again, this sounds a bit odd at the beginning, same like this 52 minutes, but if you think about it, it does make sense. Let's briefly walk through an example. Let's say you build an app using your favorite coding companion. You did so, and you're running that app now on a Kubernetes cluster of your platform team. Everything is great until you run into an error. Something is not working anymore. So the first thing you will have to do is to learn about the issue and to understand it. You will dive into logs, you will digest all the metrics. You will likely need to interface with your platform team because you get the whole error message. Maybe you will even have to learn Kubernetes yourself. So the abstraction the platform team broke, and now you need to dive into Kubernetes, which you actually wanted to prevent. Then you need to design a solution, decide for it. Then you write the changes, the actually coding part. You do the pull request, review. Maybe you update your observability and monitoring tools. Then you deploy the fix into production. Maybe that was not the first time. Maybe that happened multiple times, and you decide you actually want to move off Kubernetes and have all the accountability and all the influence in your team. So you want to go to full serverless. And that's a great idea, but the cycle of development starts again, right? You first need to understand and learn about the technology, design an architecture, decide for it, develop, review, monitoring, and test, and maintain it. So the question is, if it's not coding companions, what do I need to flip that equation, to actually give the developers more time for innovation and transformation and not for running and maintaining apps? And the answer is, what you need is it's a development companion, so much more than a coding companion. The development companion shall help you across the whole software development lifecycle, understanding and learning, deciding and designing, developing, reviewing, monitoring, testing, and maintaining. So if you go through that basically step by step, let's start with understand and learn. What you likely do, let's say you're new to a company, new to a team, you have new responsibilities, maybe you want to develop a new feature. First thing always is understanding and learning, right? Non-functional and functional requirements, what's the existing environment. So you will dive in documentation, and then you will decide and design for an architecture. And there's actually a cool concept by DevX, and that is called knowledge discovery efficiency, or in short, KDE. So the KDE is a value, like a number between 0 and 100. And it's calculated for each developer individually, and basically signifies the knowledge the developer lacks or doesn't lack to complete a task. So when the KDE approaches 0, there's a lot of information missing. You'll need a lot of research. Maybe you need to learn new languages, tools, frameworks. This induces high cognitive load, and this is not what we want for productivity, right? When the KDE value approaches 100, this signifies a solution where there's basically no information gap. Everything is well known. And I hope some of you guys know Star Trek. There's this guy Q, almighty and all-knowing. And like he will be like one of the few persons having a KDE score of 100. And why I'm saying that, the question is, can GenAI help us to build an all-knowing Q, an all-knowing entity, which we can simply interact with, which we can like ask the questions so that we don't have to search ourselves and do all that work? So is there a solution to increase the KDE value for us? And yes, there is a solution. GenAI can help you with that. Let's say you want to first understand the existing app requirements, use cases, and you know everything is well documented, right? Somewhere, but where? And this is, by the way, the reason why they call it search engine, not find engine. It will keep you searching. And the potential solution is just ask your all-knowing development companion to give you an overview about the app. And why does it know? It knows all your internal documentation. There are a lot of plugins, so it's very easy to integrate Atlassian toolset, web scrapers, GitHub, GitLab, whatever you need, wherever your data points or your data is, to get an understanding. Maybe the next step is you want to not only understand all the use cases, but maybe you want to add a piece of functionality. And for this, you will start with the user story. User story require technical knowledge, right? How is the app built? What would I need to change to actually do it? The development companion knows your environment, can do so. And in this case, I can even ask it, hey, cool, I like that user story. Please give me a Jira task for that. And you can do that. And with this, the development companion really helps you from understanding until writing a user story based on your internal documentation. And this is increasing your knowledge discovery efficiency, right? It's shortening feedback loops and reducing your cognitive load. So there we go. And the next step is you likely want to design an architecture and decide for it. But maybe you don't know if the services you want to use are allow listed. So what you should not do is shoot an email to the CCOE, right? Long feedback time, like you don't want long feedback loops. Simply ask your development companion if those services are allow listed. And there we go with the answer. 2 of them are allowed, 1 is not. So why does the development companion know? Again, it knows your internal documentation and it knows your service control policy. So the next step would likely be, I want to add the missing service to the allow list. And there I get a step-by-step manual on whom do I need to contact with which information to actually get the service allow listed. This is shortening the feedback loops and overall increasing your productivity. The next step in the software development lifecycle then is develop and to review. Again, it starts with understanding. There's always understanding involved. And also there, your development companion can help you. You can simply ask him, what does my code here actually do, right? Hopefully it's not your own code and you need to ask him. I heard that happening too. But maybe it's like an existing code base and you're in a new project. And you can ask it, hey, help me, what is the code actually doing? How does it work? Maybe it's a language you don't know yet, or you're not very good at, or still learning. And there you go, right? This is an answer. Also explain, okay, why is your UID used and for what is it used? And the development companion really knows your environment. So you can even suggest improvements, or you can ask it, hey, how to best deploy it in a serverless way. If you want to add test cases, and you should always aim for higher test coverage, right? It can help you with that. But maybe you really want to go way beyond that and even develop a whole feature. You have that code base, right? And you want to add a piece of functionality. You can ask your development companion, hey, please implement an add product function. And as it knows your environment and your internal documentation, it can do so. The first step will be you will get a step-by-step approach on what is going to be changed. You can see what it will change. So it will also update your tests. You get the step-by-step, and then there's a smart action button telling you, hey, you can please write me code for that. And this will take a little bit longer than what you've seen just now, but then it generated code for you, and you can simply review it. And same as what you would do with an internal colleague, right? You can provide feedback. And if you're not happy with something for whatever reason, ask for an iteration. Ask for an alteration to change something what you don't like. And there you see that product functionality is added. And at the bottom, we even have test cases. Okay, so that's quite cool. The next step in the development process is monitoring and testing. This can be frustrating at points when you get error messages which you don't understand. This is a very easy setup in the cloud using a Lambda function. And you may run into an issue when you first build something and test it. Ask your development companion to help fixing it. First step is, again, understanding. So lengthy error message, what does it actually tell me? And it tells you, hey, you lack permissions. You need to have a different permission set to be actually able to put something in the DynamoDB table. And the development companion then is generating a resolution for you, right? So it helps you understand, but it also helps you to fix the stuff. And that takes a second, and there you go. Those are the recommended steps, right? Step by step, but maybe you don't want step by step. Maybe you even want an immediate solution available. And then you can ask your development companion, hey, give me an immediate solution. This takes a few seconds again, but this also reduces feedback loops and reduces the cognitive load and will help you to stay in the flow. You can copy it, and there you have your solution. And at the bottom, there's always the opportunity to provide feedback. Right? We always tell, work backwards from your customers, work backwards from your users, and like providing feedback will help to continuously improve your development companion. The last step in the software development lifecycle then is maintaining. We've learned a lot of people spend a lot of time there, right? And not everything about maintaining is a lot of fun. Thinking about, you have COBOL code, you have old Java code. Very hard to upgrade it to more modern languages. Think about COBOL to a modern language, or think about Java 7 to Java 20 plus. And the development companion should actually be able to help you here. The first step a development companion does is basically copy the code in a managed and secure environment. And then it starts to create a transformation plan based on some static rules, powered by some LLMs to fix everything which is not covered by static rules. And then it starts actually building and iterating over it. And you can follow that process in the transformation hub. And the last step basically is transformation is completed and you can review the code and see that it actually builds. And this will help you in the maintenance part of the code. So to overall sum up, the first thing we've heard is developer experience is likely the best metric for developer productivity. We heard that platforms and tools can really help to increase developer experience, but only if you truly work backwards from your customer. So think about shortening feedback loops, increasing cognitive load and flow time. Make sure you interface with your users and customers. If you don't have a mechanism in place for doing so frequently, get a mechanism in place to actually have an institution on doing that. When thinking about working backwards, think about 52 minutes of coding per developer per day. Think about 73% running and maintaining, and only the rest is spent on innovation. So this is why we say coding companions are great, but what you need is a development companion. You need a development companion who really helps you along the software development lifecycle, from understanding, developing, testing, upgrading. You actually want, like Star Trek Q, you want an all-knowing mentor who you can simply ask questions to get answers instead of diving deep in every problem yourself. And we've heard from Robert that platforms do provide abstractions, and that can be great, but those abstractions can be illusions, and if they break, they leave your developers helpless. So our call out basically is spend less time building the perfect abstraction. Instead, have a development companion actually explaining stuff to you. And that's it. Thank you a lot for listening in.
Christian, Robert, hello again. Thank you so much for the talk and for the demos. It was very insightful. Since we have only 5 minutes left, I would say we jump right into a Q&A. First, you got a question to the audience. Do you work in a large enterprise, and does your company use coding companions at scale? Just write your answer in the chat and we will forward it afterwards. So, and we will make use of the last 5 minutes and jump to the first question. It was too big for a banner, so I will just read it to you. While agreeing with all the points, there's still the practical issue of who owns shared systems like CI/CD infra, observability, test tooling, or shared KAs, clusters. Some third-party tools still require this. Separate teams or dev teams?
Yeah, for sure. I mean, first things first, yes, you will always have some basic IT services like networking and so on that somebody has to share. There are services that you need to run in platform teams simply because they are built in a way that is centralized. So you need a centralized team to run them. That's for sure. The option you have, especially with cloud, though, is that a lot of services you can actually run as separate instances for individual developer teams, and that can make it much easier to run in a more decentralized way. One more thing about sharing or sharing responsibility is I am of the opinion that as you progress, at some point the developers will know more about the services they build on than the platform teams. We already see that, for example, with serverless, right? With serverless, the platform team doesn't have to do much, but actually developers know all the small problems and things they need to know to really employ serverless in a good way. So this is where we really advocate for like a shared responsibility system, meaning you are collaborating on things like templates and best practices.
And this can only work well if you really interface with the users frequently, right? And not via email. Have a mechanism in place.
Right. Thanks for the answer and the tips to both of you. Our next question is a more general one. As companies grow, what should they do to keep developers working efficiently?
My short answer would be try to apply the DevX framework. Do you want to add something, Christian?
No, that's a great question, and there are tons of dimensions to it. But yes, the DevX framework is a really great tool to look at all dimensions, right? From satisfaction, collaboration, efficiency. It covers it all, and it forces you to frequently interact with your developers and to figure out what you actually need to do to keep developers working efficiently. Talk to them; they will tell you.
All right, thank you for this as well. Next question. How do remote or hybrid work environments impact developer productivity, and what can be done to improve it in these setups?
Oh, that's a good one. Actually, I think I'm not really the expert on that part. So I think Christian and me, we're focusing a lot on productivity in the sense of a lot of the work the developer has to do as an individual person. We're thinking about collaboration, as we said before, specifically in collaborating on templates and best practices. I have to say, really, for hybrid work environments, I think I'm not the best person to answer that.
I have to agree. It's a great question. The answer.
All right. Then we have time for maybe one last quick question. Maybe this one. What are some ways to measure if developers are working productively?
Yeah, I think I think that's what I tried to show you with the 3 layers of the DevX framework. So you can ask developers, and they might tell you, yeah, everything's fine. I release once a year, great. And then you basically base that with the workflow metrics that you also try to collect to see, like, okay, this developer thinks it's fine, but actually the metrics could be better. So that's how you're trying to look at both of those things together, and then you're discussing with the developers, do you really feel productive, or could this be improved?
Telemetry data plus surveys and frequent discussions. This is the best way to also know where to look for further improvements.
All right. Then thank you for the answers, and thank you also for the amazing talk. It was a pleasure having you. Sadly, we ran out of time, so to the audience, if you still got some questions to them, reach out via their socials. I think Robert is is nodding already. They will gladly answer those as well. So yeah, Christian, Robert, thank you so much for joining us today, and hopefully we see each other again on another live day.
Thank you a lot for
Thanks a
listening
lot for
in.
having us.
Thanks, guys. Bye.